Good morning, everyone. Welcome to our presentation in the HADR series webinar. My name is Brian Farrell. I am a senior SQL architect, lead engineer, and production DBA, heavily focused on HADR implementations across various industries. The topic today is always on availability groups, commonly referred to as AOAG or AG. AOAG is one of the main HADR features in the SQL Server product. It has become Microsoft's Cadillac HADR solution, a very popular feature set. Before we get into AG, let's take a quick minute and discuss what are HADR and a couple key principles. HA is a technology solution that provides uptime for application databases, typically 24/7 type, either planned or unplanned outages. DR is taking action after a failure occurs to ensure that data is recovered and available again for applications and processes. The two key principles I referenced are RTO and RPO. RTO, recovery time objective, is a maximum allowable downtime when a failure occurs. RPO, which is recovery point objective, is a maximum allowable data loss when a failure occurs. Your goal is zero data loss and the fastest possible recovery to an online state. In terms of use cases, we see a lot of companies implementing always on availability groups when they need to provide uptime for their databases, whether it's an in-house application that requires the uptime or a financial institution that requires HADR across multiple data centers. Okay, always on availability groups released in SQL Server 2012. Always on offers a broad range of configurations and options. It is used in on-prem solutions, cloud, and also hybrid implementations. We see a lot of companies today that are bridging their on-premise infrastructure to the cloud by having nodes on their primary data center and nodes in the cloud, and those nodes are added to Windows Server failover cluster. A quick note that within SQL Server, there are other features that play a role in HADR, such as replication, log shipping, failover cluster instances. The key distinction between these is that they operate at a different level of the data. Always On provides maximum availability for a set of user databases in the Enterprise Edition version of availability groups. And note that the Enterprise Edition of SQL Server and the Standard Edition of SQL Server, there's differences in how Always On is implemented. You will, in the Enterprise version, you will typically create a different availability groups for groupings of your databases that you want to fail over as a unit. Failover is at the availability group level. AG supports up to 9 AG replicas with 1 primary and up to 8 secondary replicas. This is in the latest release of SQL Server. A common use case for secondary replicas are offloading any reporting applications or backups. This is a good method to use all of your hardware infrastructure and to maximize performance across the whole system. The two main data movements are synchronous commit and asynchronous commit. This means that transactions in synchronous commit have to wait for the log block to be hardened in the secondary replicas before releasing control back to the application. In asynchronous commit, the control is passed back quicker, and we typically see the async mode being utilized when there are multiple data centers or there's quite a physical distance between the primary data centers and your DR data centers. Always On offers a comprehensive dashboard that shows a complete view of the current state of all your replicas and the flow of data between those. In the latest release of the product, AO has improved its internal processing and log block, and this has increased performance. Next is Always On architecture. Required is SQL Server installed on each of the nodes. The Windows Server failover cluster provides the resource management capabilities and responsible for resource online, offline, quorum, and health monitoring. Once the Windows cluster is created, you can then enable the always on feature in the SQL Server configuration manager. At that point, you can start building your always on groups, adding always on databases, and then creation of the always on listener. The listener is where you point all your applications to. The port configurations are set for the database engine, always on listener, and the always on endpoint. We sometimes see stacked builds where we have multiple engines installed and always on installed on top of those. It's important in that design to document all those assets and ensure that the AD objects and the DNS records are well documented for each. With multiple data centers, we see different subnets, and the listener has those in its configuration. The flow of transactions in an always-on configuration is via a log block. I'm showing on this slide the synchronous commit processing, and there's another diagram for the asynchronous commit flow. This diagram here shows how a transaction moves from the primary node to the secondary nodes to the log cache, log pool, and eventual log flush on the primary node, and simultaneous sync those over to the secondary nodes and to harden those transactions. If you're in a busy OLTP environment and need to see the timings on those internal processing steps, they can be viewed by setting up an extended event session. The underlying foundation to the always-on feature is the Windows Server failover cluster. There is no shared storage added to the Windows cluster in AOAG setup. Each node in the cluster has its own storage. It is very important that each node have the same storage configuration, naming convention, and speed. There are a number of configurations that may need to be fine-tuned, and a few are listed in this slide. Health check timeout, lease timeout, cross subnet delay, and same subnet delay. Failover Cluster Manager is the user interface for the Windows cluster management and will show the always-on groups in the roles section. Some common operational tasks here are analyzing the cluster logs, analyzing the cluster events, and monitoring the Paxos tag to check that the cluster is synchronized across the full system. Here is a typical always-on setup. We have a primary data center with 2 replicas created in it and 2 separate DR data centers with a single replica created in each. Applications will point to the always-on listener, and the read-write traffic will be routed to the primary replica, and optionally, any read-only traffic can be routed to the secondary replicas. The read-only traffic can be configured in the always-on configuration pane. Backups are ran in DR1, reports are ran in DR2. Here we're taking advantage of all the available hardware infrastructure. We also see differences in the sync methods, with synchronization mode in always on from the primary to DR1 and asynchronous mode configured from the primary to DR2. The reason for this is the longer physical distance between the primary site and DR2. That concludes the presentation for today. Thank you very much for attending. Feel free to reach out to us at info@novadba.com for any questions relating to SQL Server Always On availability groups.